Hello everybody, welcome to a new lesson. Today we will be studying a new concept which is the indefinite integral. So the first thing as usual, why I should learn or study about indefinite integral. So you have to understand that foundation of calculus, like indefinite integrals, are a fundamental concept in calculus, and when you understand them, their understanding is essential for you for mastering more advanced topic in mathematics and related field in your life. So the reverse definition, like indefinite integrals represent the reverse process of differentiation. This help you and us understand the relationship between a function and its rate of change. Many physical phenomena are modeled by differentiation equation. Solving these equations often require finding the indefinite integrals of a function. Just for example, they are used to find displacement for a vehicle or the velocity. If we are given the acceleration, we can go back and find the velocity, because you know that the differentiation of the velocity will give you the acceleration, but the integral of the acceleration will give you the velocity. There is one interesting question: what is the difference between indefinite integral and regular integral? For instance, we have one indefinite integral here and one regular integral here. So there are like four differences, including definition are not same, the results from them are not same, the purpose of them are not same, and the notation also is not same. So for the definition for the indefinite integral, it represents a family of functions. It includes a constant. There is a constant. So how we write that? We write it as this: the integral of f of x, the x is equal to fx plus c. So it is a bunch of functions that its derivative will satisfy the given function. The only difference is they have plus different constants. For instance, if I have this function and I want to find its integral, it will be x squared. However, x squared is not the only one that actually if you take its derivative will give you 2x, but if also x squared plus 1, if you take its derivative will give you also 2x. Same thing for x squared minus 3 or minus anything, it also give you, if you take its derivative, it will give you the function 2x. So for the regular integral, represent the accumulation of quantity. This is representing one accumulation of quantities, such as area under curve. If you have curve like this is the integral. It has also a specific limits and result in numerical value. So in other words, the regular integral have some limits. It has limits for its integral, and we usually write it as integral of from a to b of fx, which equal to f of b minus f of a. So you can see they are actually different in definition. They are also different in results. So in definitive integral, the result is a function. For this one, the result is a function plus a constant. As you saw previously from the notation, which was f of x, integral of fx dx is equal to f of x plus c. This is a result is a function plus a constant. However, for the definite integral or regular integral, result is a number. So if you take the integral from a to b of your function f of x d of x is equal to f of b minus f of a, and this is a number. This is not a function. Also, their purpose are not same. Indefinite integral used to find the general form of the antiderivative of function. This is giving us the general form of the antiderivative function of our function. However, for the definitive integral are used to calculate the total accumulation of quantity such as area under the curve, its accumulation of quantity, or a total change over a specific interval of time. Their notation, as you can see from the definition here, is not same. This one have a limit interval. This one does not have any limit of interval. So let's us take one example. For example, we will identify integral. Which one is definite or which one is indefinite? So basically, I give you one example here. This is one indefinite integral and this is one definite integral. So if we calculate their integral, these integrals, we will find the integral of 3x squared dx is equal to x cubed, okay, plus a constant c. And if you take the derivative of this, it will give you 3x squared exactly without because the constant will disappear. For the other one, the integral of let us take some numbers here. For example, we will take this as 3 and this is as 1. So we want to find the integral in the interval of 1 up to 3 of this function 3x squared dx. It will give us the integral x cubed, okay, but we will stick with our interval, which will give us 3 cubed minus 1 cube, which is 26. So in summary, understanding both indefinite and definite integral is very important for comprehending the broad scope of calculus, and also when you can use one and when you can use the other. As you saw, if you are looking for a function for a trend, you need to use this one. If you are looking for a specific amount or calculating a volume or area or something like that, you need to use this one.